Welcome to another podcast. In this episode, we're going to be taking a look at how to perform inverse transforms when step functions are involved. So I have just a short example that we're going to look at. I want to find the function f of t whose inverse transform is given by 1 plus e to the negative pi s over s squared plus 1. So a couple of things that we notice immediately is the s squared plus 1 is reminiscent of either cosine of t or sine of t, depending on what's in the numerator. And speaking of the numerator, we notice here that we have an e to the minus pi s. And so let me just remind you of sort of the basic formula that we're going off here. If you take the Laplace transform of a function f of t and step functions are involved, then by definition, so you can see if there's any shifting going on here, for example, u of t minus a, or the Heaviside function of t minus a, f of t minus a, that is e to the minus as f of s. So as soon as I see a e to the minus pi s in the problem, then I know that I'm looking for a shifted version. So working backwards from this, if I'm looking at the inverse transform of something that looks like this, then I know I'm looking for a function shifted by the same amount pi, and then we have the Heaviside function there as well. So I just have to figure out what function it is I'm taking the inverse transform of, and then I know I'm going to have step functions involved. Because step functions are involved, then I have to treat every aspect of the problem using this particular formula. So for example, if I look at this, I can use the linearity property to take the inverse transform of the first piece here, which is 1 over s squared plus 1, plus the inverse transform of e to the minus pi s over s squared plus 1. Now, a week ago in class, we would have said that this first part right here, we would have just said that that was sine of t and been on our way. But now we're a little bit smarter. We know that we have to say that the inverse transform of this begins at 0. Nothing that happened before 0 mattered. And so that officially its inverse transform is the Heaviside function times sine of t. Plus here is the, going off what we had right here, this is the Heaviside function that begins at time pi, because this translates the t-axis forward by pi, so we're shifted up to pi. And then 1 over s squared plus 1 is the function, so this is the sine function, but it also absorbs the same shift. Now, we could leave the answer there, but we just got through doing an example involving piecewise functions, and it might be nicer to describe the function f as a piecewise function and see what we end up with. So if we do that, then this function is sine of t for 0 less than t less than pi. And then once we get to pi, we're going to take sine of t and add in sine of t minus pi. So this is going to be true for t greater than pi. And it's going to be 0. So let me make my piecewise a little bit nicer here. It's going to be 0 for t before 0. So for t less than 0. And so this is the piecewise defined function. If we look at the third part of this, though, sine of t minus pi is the exact same thing as negative sine of t. So what we're really looking at here is the following function, f of t equals 0 for t less than 0, sine of t for t between 0 and pi, and 0 for t greater than or equal to pi, which we have a name for that. That is simply just the Heaviside function on 0 to pi. times sine of t. So this is what we were looking at for this particular function. Its inverse transform is its transform, excuse me, is 1 plus e to the minus pi s over s squared plus 1. So these are a transform pair. So it pays to look at the finished product in terms of piecewise functions sometimes, because you can greatly reduce the thing that you're looking at. Just remember that anytime that step functions are involved, you have to be thinking of these formulas that we've developed in this set of lectures. You can't just say the inverse transform of 1 over s squared plus 1 is sine t and then just go on your way. If there's step functions involved, you have to make sure that everything starts at exactly the right place. All right, thank you for watching.